Hello. In this short lecture I will give you a proof of the Pythagorean theorem. Pythagorean theorem in a right triangle actually says that the square of the hypotenuse, this is the hypotenuse, is equal to the sum of the squares of the perpendiculars. The square of A plus the square of B equals to the square of C, or A square plus B square equals to C square. Okay, so let's assume that the right angle triangle ABC is the right side of the drawing, and we want to prove that A square plus B square equals to C square. Now, a copy of this right-angled triangle actually was built along the length of side A. We drew the side B, and we raised a perpendicular whose length is the length of side A. So the angle between side A and side B is 90 degrees because A is perpendicular to B. Now we have two triangles, ABC in the right and triangle ABC on the left, whose two sides are equal to each other. A in the right triangle is equals to A in the left triangle, and the B in the right triangle is equals to B, to side B in the left triangle. And also the angle between these two sides equal to each other. The angle between side A and B is 90 degrees because it is a right angle. It is a right triangle. So the angle between side A and side B is 90 degrees. And also the angle between side A and side B here is 90 degrees because A is perpendicular to B. So therefore, the triangle ABC on the right side coincides with the triangle ABC on the left side. Okay, so these two triangles are coincident to each other according to the rule side angle side. That is to say, two triangles that have two sides that are equal to each other, and also the angle between these sides is equal to each other in both triangles. So the triangles can go end. They are coincides to each other. As I explained you already, A in this triangle equals to A in this triangle, B in the right triangle equals to B in the left triangle, and the angle between A and B is 90 degrees in the right triangle, and the angle between side A and side B is also 90 degrees in the left triangle. For this reason, the triangle ABC in the right side is coincides to the left triangle. Okay. And since the third side of triangle ABC on the right side is C, then because of the overlap of the two triangles, then the third side of the left triangle ABC is also C. So this side is C, and so this side is also C. Okay. So let's mark the angle between sides A and C with alpha. The angle between side A and side C in the right triangle ABC is alpha in the red color, and also the angle between side A and side C is alpha in the red color. As we know, the sum of the angles in a triangle is equal to 180 degrees. In every triangle, the sum of the three angles is 180 degrees. Therefore, the angle between the sides A and C will be, suppose that this angle is x, we don't know what angle it is, so we will label it as x. So x plus 90, this is 90 degrees, we know that is 90 degrees. X plus 90 plus alpha is equals to 180 degrees. That is the rule for every triangle in the world. The sum of the three triangles in every triangle in the world is 180 degrees. So also here, x plus 90 plus alpha is equals to 180 degrees, as you can see here. X plus 90 plus alpha is equals to 180. And here we can deduct 90 degrees from the two sides of the equation, and we will get x plus alpha is equals to 90, and if we subtract alpha from both sides of the equation, we will get that x is equal to 90 minus alpha. Okay, so as you can see here, x is equals to 90 minus alpha. And since the sum of the angles on a straight line is 100 degrees, then the angle between the sides C and C will be, since the sum of the angles on a straight line is 180 degrees, the sum of the angles in the line AB is 180 degrees. So alpha plus this is unknown angle that so we will label it as y. So alpha plus y plus x is equals to 180 degrees, but we know that is x equals to 90 minus alpha. So we can write that alpha plus y plus x that equals to 90 minus alpha is equals to 180 degrees. Then alpha minus alpha is equals to 0, and if we subtract 90 degrees from both sides of the equation, then we will get that y is equal to 90 degrees. So y is a right angle. Okay, y is a right angle. Now we will calculate the area of this trapeze in two ways. The first way is that we know that the area of a trapeze is the sum of the parallel sides, that is a plus b, times the height of the trapeze, that is a plus b, divided by 2. So it is the sum of the parallel sides times the height of the trapeze divided by 2. So in total, the area of the trapeze will be a plus b, the sum of the parallel sides, times the height, that is a plus b also. You see that the height is equals to a plus b. This is the height, a plus b, divided by 2. So it is actually a plus b squared divided by 2. Okay? So it is the first way to calculate the area of this trapeze. Then we can calculate the area of this trapeze in a second way by actually the area of the trapeze is equals to the areas of the three triangles that the trapeze consists of. This triangle, the area of this triangle plus the area of this triangle plus the area of this triangle is equal to the area of the trapeze. Okay, so the area of the right triangle is equals to the base times the height divided by 2. So it is a times b divided by 2, or ab divided by 2. And the area of this triangle is also the base of the triangle times the height divided by 2. So it is b times a divided by 2, or it is ab divided by 2. And the area of the middle triangle is also the base of the triangle times the height of the triangle divided by 2. So it is c times c divided by 2. So in total we will get that the total area of the trapeze is the sum of the areas of the three triangles, and it is actually a times b divided by 2 plus a times b divided by 2. It is the area of those two triangles, and the area of the middle triangle is C times C divided by 2, or it is 2 times AB divided by 2. 2 divided by 2 is 1, plus C squared divided by 2. So in total, in the second way, the total area of the trapeze is A times B plus C times divided by 2, C squared divided by 2. And by comparing the two expressions, we will get the Pythagorean theorem. Of course, the area of the trapeze, as we calculated it in the first way, is equal to the area of the trapeze as we calculated in the second way. So we will compare these two expressions, and in this way we will get the Pythagorean theorem. So actually we calculated the area of the trapeze in the first way, and we got that the area of the trapeze is A plus B squared divided by 2. And when we calculated the area of the trapeze in the second way, that is the area of the three triangles, yes, we got that the area of the trapeze is C squared plus AB, because it is actually AB divided by 2 plus AB divided by 2 is equal to AB. Okay, so the area of the trapeze, when we calculated it in the first way, is equals to the area of the trapeze when we calculated it in the second way. Now we will multiply the equation by 2. So A plus B squared divided by 2 times 2 is equals to A plus B squared, and A plus B squared is equals to A plus B times A plus B. C squared divided by 2 times 2 is equals to C squared, and AB times 2 is equals to 2AB. Okay. Now we will open the brackets, and A times A is A squared, B times B is B squared, and A times B plus B times A is 2AB, equals to C squared plus 2AB. Now we should subtract 2AB from both sides of the equation, and the next expression that we will get is A squared plus B squared equals to C squared, or in words we can say that the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. Okay, A squared plus B squared equals to C squared. And actually that's what we wanted to prove this equation. Okay. Actually, this proof is presented in the first time by the president, previous president of the USA, President Garfield. He was the 20th president of USA in 1976, and he presented this proof. But in the internet you have about 30 more proofs that you can see. Okay, thank you very much.